This is Marat Karudinov, and in this video I'm going to show how to create global initial boundary conditions using ERA5 data. And this video is for those who have access to NCAR supercomputer, because ERA5 datasets are readily available on that computer. For those who don't have access to NCAR, please watch another video that specifically addresses those users. Okay, so let's go to global data directory. Here we have NCAR scripts. By now, I hope that you already have NCAR command language installed on your system, and this video follows the video that describes how to create invariant datasets. So first you need to create invariant datasets, and after that you use this video to create boundary and initial conditions using ERA5 data. So here we start with soil, initializing soil using ERA5. For that we use this script for NCAR, init soil. Okay, here what you need to specify, like we did for invariant dataset, for global invariant dataset, for this grid 3840 by 1920 divar. So you specify that grid here, and also data. Let's do some simulation of Irma, Hurricane Irma. So this one was in September of 2017. We start on September 5, when Irma was far away from the US, and we will run it like for 7 days. And in the following video I will show how to set up name list for this particular case, and how to convert output files to netcdf as a result of such a run. So we use here you specify the date. Again, datasets already available at NCAR, so all you need to do is just specify a date here. So it's 2017, month is 0.9, which is September 5th. Now if you want netcdf files outputted, so all these datasets also have duplicates in as netcdf files. Just for checking, model does not use netcdf files as input. And also you need to already you specified symbolic links to binary output and to netcdf output. How to do that, you need to again to watch video on invariant datasets. This is the just path to data at NCAR that we will use. Those are hourly ERA5 datasets. Okay, so after you did that, everything is set. You just execute that script. It will take several minutes, so I will pause the video. Okay, after a few minutes you will create datasets. The script will create these datasets. This is kind of output. What to watch here is that your temperatures are in a reasonable range. This is soil wetness in reasonable range from 0 to 1. So everything looks in order, everything is fine. So now we will create snow dataset. So for that we will use script make 2D init snow ERA5 NCAR, again for NCAR. So here we specify our grid, and here we can ERA. This is initial dataset, so we specify only initial date when the run will start. So it's a 00Z on September 5th, 2017. So you specify netcdf output if you want, just to check the datasets visually if you want. Okay, so everything is set here. We just run the script. I will pause the video, although it will take maybe I will not pause. It will take, actually I will pause. Okay, so that's a very short running time. So basically what it creates a global map of snow depth and snow temperature. So you see that values are in pretty reasonable range. Snow depth in meters, so maximum is like 10 meters, is capped at 10 meters. Okay, so now let's create the evolution dataset, which is SST. It could be just initial, sea surface temperature and sea ice cover. It can be, we could specify evolution it over a simulation period, or if we want to do forecasting of hurricane, then we only know sea surface temperature at the beginning of the run. So for that case we could specify only one particular moment, but let's specify SST for the whole period. So for that we edit this file, evolve SST CI ERA5 NCAR. Okay, so here again we specify the grid. Our grid is 3840 by 1920 die bar, and here I already set dates for ERA. So we will generate 7-day dataset. So we will start on September 5th, and it will run through September 12th, 00. And if you want to specify only one time, only initial SST, in that case your date end should be the same as date start. That's all it takes actually. The advantage of initial of just specifying one time step, that model does not care about timestamp in that data, so it will read it regardless of its actual time. That's the only difference. Okay, so now also we need to specify hourly. It's probably overkill to specify hourly SST. First of all, it takes pretty long time, and also if you specify hourly data, just changing hourly, that would take a lot of storage too. So we will skip SST. We will record only every 6 hours, and for ice only every 24th hour, so daily. It's not gonna do averaging, so it will just skip a certain number of ERA5 data points, time points. So this will be our 6-hourly SST dataset and daily sea ice dataset, but again without averaging. So we can specify output, and is netcdf for checking. So this is our output directories as usual, and that's all you need to specify. Okay, so let's execute it. This one will take longer, so I will definitely pause the video. Okay, so it's done now. We have again check temperatures if they look reasonable. This is ice cover, so from 0 to 1, of course. Okay, so we're done with this. Now basically we are done with data set that conform to the grid. So they basically specified on the same grid as your invariant data sets. So these data sets like soil, SST, ice cover, and snow, they should be on the same grid. So now initial data sets like three-dimensional ones, initial nudging data sets or zone data sets, those are three-dimensional fields. They don't have to be on the same grid as your model is going to be run on, because model will interpolate those data to a required grid. It's not the case with SSTs and others because it's more complex. There is land, sea kind of boundaries, so it's better first do it kind of offline than using a model for that. So let's first specify initial conditions for atmosphere. In that case, we use make 3D init NCAR script. So this script computes, not interpolates, but writes initial data for velocity components, UV, for temperature, water vapor, cloud water, cloud ice, rainwater, and stuff like that. So okay, so here what you specify, here you don't specify your grid because, well, your initial dataset again is not going to be on your model grid, it's going to be on ERA5 grid. So we specify only date. This is initial dataset, so we specify only one date. So this is our ERMA case, so by September 5th, 2017. Now we put some identifier so that the initial dataset would have some identifying flag here in their name, so that it would be easily found, and to make sure that that this is global dataset. So I specify here a global. netcdf out. Well, I don't output netcdf here. It's pretty big files, three-dimensional ones, and those are standard symbolic links. So basically, the only thing that you specify here is just date, and then you run it. This runs pretty quickly, so I won't pause the video. So you see it's Q, QC, QI, QR, QS, so done. Okay, now what is left is to create ozone dataset. For that we use make 3D ozone NCAR. And ozone is what I use usually is monthly data, not daily. Well, ozone is pretty slow changing thing, and there is no really point of, at least in my opinion, to specify it more precise than that. So here slightly different interface. So if you want an NCDF out, that's what you specify, and then you specify basically months, starting months and ending months of data set. Like in our case, it's September 5 to 12, 2017. So year start 2017, year end 2017. But month start should be so that the model could interpolate ozone dataset. Should be 1 month before and 1 month after. So before September, which is 9th month, it's 8. And after that it's month 10, so that's what you specify. Then your identifier is again global, it's a global dataset, and then you just run it. It should be very quick. Okay, so that's basically it. Let's check. We will check data that we specify, like it's 3840 times 20, I mean 1920, and also global. This is our 3D data sets. So let's, okay, so this is what we have, basically all the sets that we need for global run. So this is ice mask, which is sea ice, initial data set for 3D fields, leaf area index, land mask, land type, ozone data. Well, this one is I need to erase it. This is some data set that previously was created. Yeah, so ozone, snow. This one's just, this is snow depth, snow temperature, soil, which is composition of soil layers, like clay, sand stuff. So this is invariant data set. And this is initial conditions for soil. This is sea surface temperature data set and terrain. So that's basically it for this setting this up, and watch the video where I will edit the name list for this Hurricane Irma case, and run it and see some results, and also show how to convert output datasets in native model format to NetCDF all at once. I mean, very quickly, not one at a time, but many at a time. Okay, thank you for watching, and happy computing.